Thank you for the. Oh, you wanna? Make sure you go to the front later once a while. Huh? Okay. Cepat Amoy. Dia orang makan dalam lab ke? Kena makan seorang-seorang je.
Doktor makan-makan.
Ha?
Makan-makan.
Mana sahaja?
Doktor belajar.
Belum dapat gaji lagi. Mana nak belajar?
Dia pula gaji, kita belajar.
Tu gaji tahun depan. Okay, our next part a bit difficult. Is Gauss law. Okay. But before we look at Gauss law, we are going to look at this much more basic thing we call electric flux. Right? Electric flux. So we have to look at that one first. So under this one is A. Electric flux, the symbol is an I with an O combined. We pronounce this one as Phi. Okay? Phi. Now, nowadays, because we got test 1 and test 2 separated, right? Not like last time you have a final exam where your final exam is from chapter 1 until chapter 8. So now your chapter 1, 2, 3, 4 is test 1 and 5, 6, 7, 8 is test 2. Now the magnetic field is in test 2, electric field is test 1. So magnetic field you also have magnetic flux, right? And electric field have electric flux. So nowadays there is no problem like wrongly use of symbol, for example. But last time we had to differentiate them. There are two phi that we have. For electric field we have phi E, right? And then for magnetic field we have phi B. So this one is called magnetic flux. Okay? Because if you simply say give them a symbol phi, students get confused. Okay? So we have to give them two different symbols. We subscript B for magnetic field and then E for electric field. Alright? But now you don't have that problem anymore because your file B is not going to meet file E because they're separated by a time of 6 weeks time. Right? So the next one will be your magnetic flux. So you have no problem in getting confused. It's an equation used anywhere. Alright? Now what is electric flux actually? We have to define the equation first. So electric flux is defined to be the dot product of electric field vector, which is E with the area vector. Okay, area vector A. Okay. So formula will be this one is equal to E dot A. So since dot product is a scalar product, so phi is actually a scalar quantity. Okay, it just tell you how much of that electric field passing through a surface, right? Now, if you remember, what is the formula for E dot A? Anyone? What is E dot A actually? EA? EA what? What is the formula for E dot A? Ini siapa aja visit 110 ni? What is a dot product formula? EA cosine theta, right?
Yeah.
EA cosine. Yeah, now yeah. I told you so. Yeah. Okay. Then there is another what we call that function also is called the cross product, right? So dot product is EA cosine theta. Then the dot product will be sine theta. Okay, sine theta. There's only two that you need to know. Later when we go into magnetic field, you know what is the cross product. Electric field mostly we use dot product. Magnetic field we're going to use cross product because dot product normally is for magnitude only, but cross product is a vector quantity. Magnetic field is much more complicated than electric field. Okay? So that is the formula. Now we're going to look at what it means by that. Okay? So let's assume we have a surface area. Okay, a surface area that big. The side is A, the width is B. Now we place this surface area inside a electric field. So this electric field, the electric field region is larger than the surface area. So we have this electric field pointing to your right hand side. This is the one that passed through it. Like that. So we might use dotted line to represent actually it go behind. Okay. So we have electric field E. Vector E. Now the question is, where is the surface area that we are talking about? There are two surface areas, right, in that object. Okay? In that object, for example, now there is an object we're talking about. Okay? So one of the surface area is the one that facing you, the one that you can see. Another one is behind, you cannot see it. So that means if there is an object with two surface areas, then it will have two vectors. Okay? Two vectors. That vector, actually you learn it in Form 4, Form 5. But you don't use it at all for any calculation. And you don't even call it a vector of area. You call it by a name, normal line. Remember that? From a surface, if there is a line perpendicularly from the surface, you call it a normal line, right? You use it in optic, remember that? Optic, like lens, reflection. That line actually is a vector for the area. So we write that vector of area like this. We choose one of the convenient electric field, we choose this one. So that vector is actually pointing out from the surface at 90 degrees. Okay, 90 degrees, and it is given a symbol vector A. Okay, that is the A that we're talking about. So this vector A is normal from the surface, 90 degrees, but it is making an angle theta with E. Okay, making an angle theta with E. So this is a theta that you are using. Sometimes question can trick you, giving you another angle, the other side of the angle, which is wrong. That angle is called glancing angle. So if we draw a line like this, reference line, okay, so that angle normally we give it a symbol alpha. Okay, symbol alpha. You don't use alpha, you use theta. So alpha is called the glancing angle. Okay, glancing angle. We don't use glancing angle except when you take Physics 310, you are studying X-ray. Then you use glancing angle. Okay, because X-ray don't have this angle, right? So now we have A, theta, and the A, magnitude of A is actually the cross-section, the area of the object here, which is A times B. Okay, it is A times B. So in order to calculate the magnetic flux, you need three things. Number one, the size of the object. Number two, the strength of the magnetic electric field. Number three is the angle between the vector A and the vector E. Okay? So there's no special name for that theta, but the other side you have. Funny, physics, the important thing you don't give name, but the not important one you give them a name. Okay? Isn't it easier to call people by bad name?
Yeah.
Sometimes in your class, I mean not now, maybe during your Form 1, Form 2, you have a special name for your friend, right?
Yes.
Like for example, a friend that have a kutu before, so every time you see him, oi kutu. See? Actually, you got a new name like, for example, William, Peter, such a nice name you don't call, but you like to call them kutu. And then the Pompon you call kuti, right? I don't know whether still apply to your time or not. My time, I tell you, no one have their real name called. I have a special name, Skinny. Kurus, because last time I'm Kurus. Well, not enough to eat. My family very poor last time. So Kurus. Until now, when they see me kurus, oi, look at me, still kurus. So that's it lah. Same in physics. Sometimes you want to avoid people from using the wrong value. You call that value by very special name where people remember, oh, better don't use this one because it sounds very weird. See? So it's the same like human nature. Scientists also human, but I think scientists also they have name for each other, right?
Yes.
Like Einstein, what? Einstein have a name.
Crazy scientist.
No, not crazy.
Mad scientist.
Mad scientist. They're mad scientist. Abu. Bila dia panggil Abu. Stephen Hawking call Akau lah. Alright, so this one done. We look at example. So one formula only. Before that, what is the unit? The unit for phi or electric field. We follow the formula. Look at this formula. EA. Cosine don't have unit. E is the electric field. So we have Newton per Coulomb multiplied by area meter square. But in physics, when we deal with vector, the positive power we put in front first. Put in front first. Big capital letter come first normally. So Newton, after that positive one, and this one Newton meter square per Coulomb. If you have other unit with power that is getting more and more negative, the more behind they go. So that is the way we actually how we arrange the units. Okay, arrange it so that when people see, oh, that is a unit for electric flux and so on. Okay. All right, done for the first part. Now we look at example. Okay, example 1. Okay, a rectangular shaped coil has dimensions 18. That means A is 18 and then B is 24.6 centimeter. It is placed in a uniform electric field of 250,000 Newton per Coulomb. Okay, 250,000 Newton per Coulomb. There's an E value, and there's an E. Find the electric flux through the coil if A, okay, if the coil plane, okay, the coil's plane is parallel with E. B, the coil's plane is perpendicular to E. C, the coil's plane is the coil's cannot be done.
So what is sir?
Huh?
It is plough.
Where?
1, 2, 3 baris
It
keempat.
is placed.
Hah?
Okay, the coils are area vector. Okay, is making an angle of 40 degrees with the normal. fine. Sorry. Sorry, not this one. This is another question. The coils are area vector is making an angle of 40.0 degree with the E. That's it.
Cuba baca balik sir.
You baca sendiri.
Rectangular. Shape.
Listen first. When you listen one time, then you will know what I'm writing there. Good luck to you.
Oh no.
Faham. InsyaAllah faham.
Sir,
Yes?
bukan sir.
Cantik kan?
Cantik sangat sir.
Okay, tambah 10 mark.
Yes.
Sir.
Itu you tak payah datang sudah. Tak payah datang sudah lulus. Bukan setakat lulus, A+. Andai jadi serius. Macam ni.
Blushing.
You kan apa? You turning red? Seriously?
Sir, your face right.
I'm a very,
Blushing. Your face right.
I'm a easily shy person. Why suddenly you start to talk? You're normally very quiet, right?
No.
Why are you blushing now? Kenapa sudah?
Merah muka sir.
Saya pula. Kamu nak cari hal ya?
Sorry.
Potong 5 kakak. You see, a same statement talking to someone, sometimes you get a positive response, sometimes you get a negative response. It depends on who talk to you. Wait. Ini sengaja nama record.
Sorry sir. Kami lupa sir record.
This one for our indoor use only.
Saya ingin meminta maaf.
Video masyarakat. Kalau viral ada baby kecil.
Nah, Bapak dah.
Take those in your class, right, Talia? You got Talia in your class? No, he from other class supposed to join this class, but he cannot make it. All the class he cannot make it because I think she repeat MNT 133. Anyone repeating MNT 133 here? You? No, Okay, good. Because that code is going to phase out already. They're going to new code. Siapa yang hutang paper to next time suffer dia? You're going to take another code, which I'm not sure whether it's in the study program or not. So anyone, tell your friend, anyone yang hutang or repeat MAT 133, better this semester you settle the problem. But why she didn't take the paper last semester? Because you are part 3, right? That paper is part 1, right? You're supposed to settle that paper in part 2. Not bring it up to part 3, because part 3 you are getting more and more difficult. Okay? If you hate maths so much, but you're a science student, you know. Science student not supposed to hate maths. You can hate physics, but love bio, I can understand.
We love it.
Oh, yeah. For now only, or forever?
However,
Forever. So are you going to take physics next time? Okay?
ni ada program.
Itu setakat nak dapat markah 10 je. Okay, done? So there's only one formula you're using. Let's have a look. That one, EA cosine theta, not this one. This one is a definition. You cannot use this one to solve. You have to use this one to solve the problem. Okay. A. Write down what you're given. You look at the coil plane. What is the plane? Plane is a surface. The surface is parallel with the E. So if your surface is parallel, with E, that means what is your theta value? your surface is parallel with E.
40 derajat sir.
Huh?
40
Okay, now we 40. 40 is a third scenario.
parallel.
You look at this one. This one is a surface. Huh?
180.
180? Kau ni dari dunia mana ni? Planet mana? Jupiter?
Maret.
Mare. Itu tempat orang gila.
Derajat
Now, this is the surface we're talking about. This surface. This surface. If this surface, we know that there is a vector A, right? Right? Like this. This surface making angle theta. Now, when the surface plane become parallel, your A pointing out from the surface, right? Like this. So what is the angle between the A and the E now?
there.
90 degrees, isn't it?
Yes,
90 degrees, right? Okay, so you have to understand, question will never give you the theta value in these two cases. You have to think about it. But this one, yes, this one is easy because it straight away give you theta equal to 40. So now let's assume this thing can actually rotate slowly. So when it is parallel, the surface is parallel with the E. You look at what happened to the A, 90 degree, right? Now when the surface become perpendicular, this surface here, don't look at this one. This surface here become 90 degree or perpendicular with the E, like this. What is the angle between A and E? 0, right? Make a 90. When this surface is parallel, this is E, right? E is this surface, right? I better draw it. This is E. Flat with the surface, right?
Yes.
So now maybe I need something thinner.
Yes. Nah, semua kertas.
Nah, tambah 5 makam.
Aku lulus
Tambah-tambah
tanpa
lepas tu
sekejap.
last tak tahu apa-apa. Alright. So you have a rectangular surface or coil. So this coil, let's say, is rotating. Okay. So there will be a condition where your plane, the surface is parallel. You see, this surface and this surface are the same, right? So we call this one parallel. So where is your A? Like this, right? Because A must be 90 degrees from this surface. So now if this is A, what is the angle between the A and the E? 90 degrees, right? Mana zero kau dapat ni?
Astagfirullahaladzim.
I repeat again, tak tahan, jangan bangun, duduk sana. So this is a coil, right? Can you imagine this is a coil?
Yes.
Okay. This coil, let's assume it can rotate slowly, not too fast, so that it can see what happens. Now, at a certain time, the coil is like this. When the coil is like this, which is actually the same on the surface, we said that the plane of the coil is parallel with the E. See or not?
Yeah.
Okay, so now we know that a surface will have a surface vector which is 90 degrees from the surface, right? So now what is the angle between the vector A and the E? 90 degree, right? Okay, boleh bangun. Now, next one. When this surface area is now perpendicular, okay. This is perpendicular, right? Because the surface now is making 90 degrees with the E. So your area is like this, right? Area vector. So now what is the angle between A and E?
0.
0, right?
Yeah.
Because they are in the same direction. Two vectors of the same direction have a theta 0. Okay? So there are so many possibilities. These are the two special cases. Okay? So I repeat again, huh? So when this one turns until it becomes like this, so this surface here is perpendicular with the E. See or not? So when you spin, your A follow. By the time this one perpendicular, your A actually is parallel with your E, right? And the angle between these two vectors is 0. Okay, 0. Okay, can take back your paper. Thank you. Clean. Okay, this one we don't need anymore. Alright, so now we know the theta for the first one is parallel, then your theta is 90 degrees.
Yes.
Okay, 90 degrees. So you can calculate the flux at 90 degrees, okay, which is equal to E and cosine 90. E is 250,000. Your A, be careful, that one is in centimeter. So multiply 0.18 multiplied by 0.246 and then cosine 90 degree. Cosine 90 give you what? Cosine 90, what's the value? You don't even need calculator for this, right? 1, are you sure? I thought 0. Cosine 90 is 0, right? Because sine 90 is 1, so the cosine is always opposite of your sine. So this whole thing is 0. Okay, 0. So when the surface area or a coil surface area or the plane is parallel with the electric field, you get 0 electric flux. Why? Because when you put it parallel, nothing pass through the area. Okay? Nothing pass through the area. Okay, that's the first one.
Sir,
Yes.
simbol selepas with ya apa?
Simbol selepas
With.
E.
Oh.
Vector E.
So, yang sebelah A cos 90 ya? E juga.
E juga. Tapi
Nah.
magnitude yang tu ada vector.
Oh.
You see when you use English, for example here, plane is parallel with E. You are talking about direction, right?
Yes.
So you should put a vector sign below the E to tell people that you are comparing the direction now. But when it comes to calculation, we are calculating the magnitude. That's why no vector sign here. No more already. You're supposed to learn that one in part 1.
Oh,
So there's a lot of more little detail about science that you have to know. Not only physics, chemistry, bio, everything the same.
cos 90.
Okay, next one.
Perpendicular.
Perpendicular.
Depan ada satu.
Yeah. Theta is what? 0, right? Why got 90 anymore? 0.
Cos 0 equal
Cos
to
0 equal to 1. So plane is perpendicular with E. You see now, I'm still using the vector sign, right? Because I'm comparing direction.
Yes.
And then the theta will be 0 degree. Okay? So your electric flux of 0 degree is going to give you EA cosine 0, 250,000 times the same thing, 0.18 times 0.246, and cosine 0, this is going to give you 1. This is where your calculation comes in. Answer is
10800.
10800. Okay? Unit Newton meter square per coulomb.
0.
0 mana?
Ada unit ke sini?
Ni,
Yang atas tadi.
this one, you want to put unit, go ahead. 0 got nothing. You can put, no, it's not wrong, you can put. No need to put actually. If no value. Okay, no value.
Wow.
Next one, with 40.
Nampak sikit. Meow, meow.
See, theta is 40.0 degrees, so this one is easy because the value already given to you. EA cosine 40, so 250,000, 0.18 times 0.246, cosine 40 degrees. Okay? Calculate?
Di sini.
Yeah? Yeah.
Dah.
What's your value? That one?
Sekejap kan.
Hai? Dekat dah.
Dah tulis.
Weh, ini tak bawa kalkulator ni. Apa hal datang kalkulator ni?
Hilang.
Hilang. Dah report polis.
Ha?
Dah report polis.
Tak rekod nombor.
Oh ya.
8273.30.
Ya.
82
8273. 8273 enough. 8273, I will give 70 because 3 significant figures. If I'm 3, that one doesn't matter because it's 0 anyway. Yes,
Yang 10
salah kan? Berapa yang dapat?
11070.
11070.
betul.
11070.
11070. So 1110 lah. Round up to 3 significant figure, correct? 11070 kan? 110. Oh, another 0 here. So this one is 0 10, right?
11070.
Oh, 70. So here is 1 lah. Like that. 11100. Okay. How about that one? The C. Okay. Correct lah.
Ya.
Correct. Sure. You calculator pun tak ada cakap ya.
Ada.
Oh, bukan you cakap. Oh, sorry. Ni dia buat dah ni. Ini mau beli taxi peng ke sini. Mana kawan ni?
Ha?
Kawan yang pergi ni mana ni?
Salah sir.
Salah lagi.
Saya tinggal
Siapa?
1-0.
Ha?
Saya tinggal 1-0 tadi.
Tinggal so kosong.
Ya dekat 25000.
How can you tinggalkan kosong? So 8480, correct? 8480. So be careful with what you are doing. 8480.
Kalian sudah.
Alright, done.
Sudah mana?
Amor, you need a small table.
Saya pass je.
Small table, we got small, you can use anything small table there. Not nice, you know. Like this, you write that after at the age of 30, you become like this.
Benda boleh surgery sir. Kalau dah kaya dah surgery.
Oh, macam aku lah ni, nak surgery next year. Oh, ni nak unlock aku ya. Don't wait until surgery happen. Too late already. You suffer already.
Better late than never.
Oh, better late than never. Oh, I didn't know you can speak. You feel that? You feel someone poke you from behind with a sharp knife?
No, already.
Already felt it so long already. Oh, okay.
Used to.
You get used to it already. Okay, good. It's a very tough word, man.
Yeah, not good.
Okay, can we continue? Second example.
Oh, keren kasih siap.
Example 2.
Dia kepada. Whether they try.
Okay. This is now a circular coil. Okay. A circular coil of 240 turns has a radius of 34.5 cm. The coil is placed in a uniform electric field. E now is 345 kilonewton per coulomb. Calculate the maximum flux, or calculate the flux linkage in the coil when theta is equal to, let's say, 30.0 degrees. Now can you read my words?
Yeah.
Can, clear that, right? I
Kinda.
can make it better if I want, but lazy sometimes. That is not my true self. You only see this once a while. Most of the time you see this.
Dia mana laban ni record.
Oh, faham pun kau. Faham tak? Sebab record, so kena tulis cantik sikit.
Sama formula pakai.
Sama. Same formula, but you look at the question, it has 240 turns, right? So that means our formula is only used for one single turn. So if you have more than that, you just simply calculate, after that multiply by number of turns.
Kira tu lepas tu
Multiply by 240, yes. Okay, this one can try. Not that difficult, just one only. Unless you forgotten the formula for the area of a circle. What's the formula for circle?
Pi r square.
Pi r square, right?
R square.
Another one?
Tak ingat.
Tak ingat? Okay, there's no such formula, it's called tak ingat. 1/4 pi d square.
1/4 pi d square.
Yeah. Why you follow every time I say something?
Follow.
Last time you were under Dr. Ahmad Lufi class, right?
Ya.
Oh. No wonder you're crazy. Right?
Lain dah ready. Jom.
What is the meaning of flux linkage? Flux linkage is actually a fancy word used to say something like total flux. That's it. When you say total, well, you just simply sum up everything, right? Flux linkage is just a fancy word to describe the same thing. Okay. So you can assume total flux. So we list down all the information given to you. Number of turns, normally you use big capital letter N, 240, and radius R, 34.5 centimeter or 0.345 meters. Next one is electric field. Magnitude is 345 kilo, so it's 1,000 Newton per coulomb. This is where students always make mistake. They forgot the K there. Okay, so the trick questions like that. Question can be very simple. They give you in centimeter, they give you in kilo value, and some more. You forgot to change one of them. Sayonara to that question already. Okay, and theta is 30 degree. Okay, so what is the formula that we use? Phi is equal to EA cosine theta, but that one for one single turn, right? If you want to do one go, you multiply by N. Okay, so it becomes NEA cosine theta. The previous question just now, our N is equal to 1. So that's why we don't put in. Okay, we don't put in there. Okay, so now we can put in the value and calculate. 240,345,000. A is pi times 0.345 square and cosine 30 degree. Okay? Calculate. Don't get the value wrong again. Huh? Kau tanya saya ada kelas atau tidak, Sarifah?
Village.
Why? Why you need to ask me?
Double confirmation.
Double confirmation.
Yes.
Cantik muka tu. Double.
Tahu sesakit tiba-tiba.
Dia ni sumpah saya sakit. Tampang saya.
Caring.
Caring.
We are caring.
Oh, okay. Caring need a hug, you know.
Yeah.
Oh, okay.
After class.
After class. Sorry lah. Not interested. Later I'll be like legend. I'm the legend who started the LGBT thing in UiTM.
LGBT.
Siapa tu? Jason Tan.
Ya.
Tak ada lah.
Dia gay.
So,
You look more straight than you, I think.
Saya
Oh, remember the word straight?
Straight.
Dah. Huh?
Saya kena dia punya mati ya.
Be careful what you say, ah. Everything we say are recorded. Ah.
Oh ya. Just your turn game.
Dah. Calculator ready?
besar betul, jawapan ni besar.
Memang besar sebab semua besar-besar.
2, 6, 8, 1, tinggal 2, 2.
Slow. Give me in standard form. 2 point.
Nama saya
6, 5, 10 to the power 6. Okay, what is your value?
7 lah.
2, 6, what?
6, 8.
8, huh?
2,
2, 6.
8.
2, 6, add 1.
1, 3, 3, 2, 2, 3, 2,
3, 2,
2, 3,
3.
point.
Bila nak point ni? Point lah. Okay, forget about the point. 2.68. Then how come this one 5? 8 or 5? 8. Okay. 2.68 power 1,
Seven.
2, 3, 4, 5, 6, 7. Yeah.
Okay.
Correct? 7. Okay. Can get the answer. You have to try it for yourself. Don't just copy. Later when come to the test and exam, then you like nak tekan calculator pun tak pandai nanti.
So, tak perlu tukar guna.
Tukar apa?
2.7 tidak apa.
2.7. Why? Why I need to change to 2.7?
Kan round tidak.
3 significant figures already rounded up. This one. 3. 3. Anyone see a problem for electric flux? Better ask now. You ask me later. I flux you, then you know. Okay, we'll take 5. Later come back for more difficult things.
Oh ya, sir.
Yes.
Itu nanometer per second.
Mana ada nanometer? Mana
bukan
satu?
nanometer pula.
Mana kamu nampak?
N meter second ke tu second? Sir, meter.
Ni kah? Newton meter square.
Okay.
Kamu ni kena adjust mata kamu lah. Dah lah paling dekat sini. Okay, next one. Gauss law.
Kau.
Okay, who is this Gauss?
The person
He's a physicist, but mostly he's a mathematician. Mathematician. At the age of 10 years old, he already actually derived the formula for something that you have learned in your Form 4, Form 5. I think that one you call arithmetic and geometric series. Yeah, he's the one who designed that one, all the formula. Okay? At the age of 10 years old. What are you doing at the age of 10 years old? Pancing ikan dia tu.
Ya, tapi dengan lot lain.
Itu tepi longkang terus kan?
Guna pistol lain-lain.
Ya, itu lain.
Alright, so there is Gauss, and Gauss' contribution actually a lot in mathematics more than physics, right? Mathematics, he got double PhD at the age of 21 years old. Where are you at the age of 21 years old later?
Not yet.
Next year. Are you sure? 2 more years.
Baru lagi.
2 more years. 2 more years. So make sure that in your 21st birthday, you better get your PhD already. Okay?
Yes.
Or else malu dah nak belajar teori dia. Alright? But his theory is actually to cover the theory of Coulomb's law. Coulomb's law was actually discovered by experiment. Okay? And it takes a long time to get a correct value. But Gauss' law is a straightforward formula that you can use actually. Yeah? So we look at the formula. So Gauss' law states that the change in electric flux across a volume of space is directly proportional to the charge enclosed by that volume. Okay? This is a word statement. Okay? The definition in words. So we're going to write down the formula. Okay, read again. Gauss' law states that the change in electric flux across a volume of space, normally the three-dimensional space we're talking about, is directly proportional to the charge enclosed by that volume. Okay? What is the meaning of that anyway? So you need to imagine that we have a three-dimensional space object. Okay, you finish copy? Yeah. Sure. Okay, first we look at, we have a volume of space. Let's choose a peanut shape. Imagine this is a three-dimensional or something like what we call it? Cempedak. When you spin it around, it becomes cempedak, right? Okay, it's a cempedak shape. Three-dimensional cempedak. Now inside there is something hidden inside. There's a charge. Charge enclosed, meaning that there is a charge Q inside. The problem is we don't know how big is the charge. Number one. Number two, we are not. We don't know whether it's a positive charge or a negative charge. All right. But you can actually expose the whole thing inside a magnetic flux or magnetic field. So we put it inside a magnetic field. We found out things like this. There are flux entering the volume. We call this one far in. Okay, far in. And then some part of the object, there will be far out. You see, when you put something inside a field, certain part of the object, the field enter, right? And then certain part of the object, the field come out from the same object. Okay? So it's same thing like, now if I put, let's say Josephson, okay? We put him inside a room, we are going to start electric field. From our left hand side, starting positive charge, and then the right hand side, starting negative charge. So that means there's an electric field from your left pointing to your right hand side. So we ask Josephson to stand in the middle. So there will be a lot of electric field punching through, enter the body, right? And then the other side will come out, isn't it? So normally, what do you think about the magnitude of the electric field that come out compared to the one enter? In normal situation, it's the same. Because you are neutral. Are you neutral?
Yes.
Yes.
Straight.
Yeah. If you are neutral, you got no charge inside, the amount of electric flux enter your body, I mean electric field per square area, we call electric flux. The one go in must equal to the one that come out from your body. Yes. Better not that. So the one that enter must equal to the one that come out if the object contains no charge at all. See here? So what we are looking for is the change in the flux, which is the phi out minus the phi in. That is an important thing to understand. Later we look at the formula. Now what if, there are three possibilities, right? Okay. So the possibility number one is this. If Q is equal to 0, that means the object no charge, then your I out is the same as I in. So what is the changes? 0, right? Changes will be 0. So that means electric flux enter, come out the same. There will be no changes in the electric flux. That one is number 1. Now come to number 2. So I have to redraw the diagram already. This one number 1. Diagram number 1. Diagram number 2. Same jumper here. Okay. Now our Q is a positive charge. Okay, positive charge. We are going to draw, let's say there are 3 flux entering. Okay, 3 flux entering. We call this one phi in. Here we can draw also. Like for example, we draw 4 to be consistent now. All 4. And this one has 4 coming out. So no problem in complaining why 4 here 1. Now this one also, okay, 4 coming out first. Initially is 4 coming out. Now because it has a positive charge. Now remember, a positive charge has electric field pointing out or in. A positive charge, surrounding a positive charge, we have electric field pointing in or out to the charge. Out of the charge, right? Out of the charge. So we have out of the charge. In this direction, we have out of the charge. This one also out of the charge. The other side not important because we're comparing only these 2 dimensions. So what is the net value now? You know electric flux, electric field is a vector quantity, right? It's a vector quantity. 3 go in, against 1 come out. Finally, what do you get? How many go in? 3 only, right?
Yeah.
Because you have a minus 1 here. Remember minus 1, so end up with this diagram now. It's going to end up like diagram like this. This one a positive charge. Now only 3 arrow pointing in. That is your phi in now. How about the one that come out? The one that come out initially got 4, but because the charge also produce electric field coming out, so they are in the same direction, so finally end up with 5, right? Yeah, so now we got 5. 1, 2, 3, 4, 5. Okay. Of course, other area also the same. Yeah? If you choose enter here, come out there, you get the same effect. So now our phi out is more than the phi in, right? Okay, so now we're going to write that value delta. Delta phi is equal to delta phi out minus phi in, and we know that this value is a positive value, isn't it? Because phi out is more than phi in. You minus, you get 2 extra. So positive 2 extra, meaning that the delta phi is a positive value. So since it is positive value and the charge is positive, then the charge is a positive charge. So our conclusion is this. If you have a positive charge covered by a space, even though you don't know what is the charge, whether positive or not, when your electric flux enter and come out, the difference between the 2 fluxes is a positive value, then you can confirm that inside there must have a positive charge. Alright? So remember this, the statement by this Gauss is, second one is this. So when you put an object, whatever object, as long as electric field can pass through them, You put them inside a uniform electric field. You check how many field enter and how many field come out in a certain direction. So the amount of field that come out is more than the one that enter. So you can confirm that charge, that particular object contain positive charge. Right? Like we put Josephson just now inside the same electric field, and then you find out the one that came out from Josephson is more than the one entered. Now we know that he's not straight, not neutral. So it must have something positive inside there. Okay, something positive. Eh? So from this, it's much easier to understand the condition of negative charge. So see, this one is number 2. Eh? This is number 2. Now number 3 is actually the same story, just repeating on it. So we have negative charge. Again, we got 4 enter initially and 4 come out initially. So that is the out and this one is the in. But we know that negative charge, you have electric field enter towards a charge. In this particular one, how many you have? 5, right? Become 5. This one you have the -1. 4 minus 1 become 3. So now the conclusion is your file out is less than the file in now. Because if you use 3 minus 5, you get -2. -2 it simply means that you have a negative charge. Right? So here, since it is less than that, our delta file is going to be negative. So negative conclusion is the Q must be negative charge enclosed inside, even though you cannot see it. Right? So, how do we measure the charge in the sun? You ask someone to go there? You cannot, right? You send someone there, they'll burn before they reach there. Halfway you already burn, even though the surface of the sun is about 6,000 degree Kelvin, 6,000 Kelvin. There is no material made on Earth that can actually handle that temperature. Okay, it's out of the question because the highest material that we have, the melting point is titanium carbide. It's around 5,000 degree Kelvin. It started to melt. So you need something else. So you need to be nice with alien. Next time you see one, don't kill them. Because if the alien can come to the Earth, that means they have a better technology. If they hide behind the sun looking at us, that means their technology are much better than ours. Okay? Shake their hand. If they got hand up. Why are you shaking his hand? I thought you are the alien.
Huh?
I thought you are the alien.
No.
The alien called Paul. You watch that movie?
No.
When what?
Yeah, well,
Alright, so now we got 3 conditions here you have to remember. Yeah? So I summarize it here. Okay? This one. Gauss law. Summary. Number 1. If delta phi equal to 0, conclusion is the charge enclosed is equal to 0. Number 2. If the delta phi is a positive value, then your charge enclosed is a positive charge. And the third one is if the changes in flux is negative, conclusion is the charge enclosed is negative also. Okay? It's a very straightforward theory, but it takes them more than 10 years to prove it in experiment. Okay? Not easy, eh? Okay? Okay, done. So now I can come back to the definition here and write down the formula. The formula is this. Change in electric flux is directly proportional to the charge covered or enclosed by the space. Okay? So now we can get a very special equation. When you turn it into equation, you need to put a constant K. Okay? But this constant K is a very special constant K. That K is actually equal to 1 over epsilon naught. So now you have a very special equation which is charge enclosed divided by epsilon naught. Yeah. Right? And what is this epsilon naught? Of course, it has something to do with electric field in vacuum of space, right? And it is also another constant. Okay? Your epsilon naught is a very special constant. The value is 8.85 times 10 to the power negative 12 farad per meter. Okay? So that is Gauss law, very simple. Later when we look at the application, it's damn difficult. Okay. Okay, you want to take 5 before you melt. Set 5 to swallow all these things. Later I'll upload the video in a YouTube and then I'll give you the link. I hope YouTube don't censor the dirty word that we say lah inside.
Saya punya muka is straight.
Saya hitangkan dia. Blur. Sorry lah, I don't know how to do I don't know how to edit that.
Suruh anak saya.
Anak saya kat Singapura sekarang.
Apa yang
Sounds good.
Okay, continue. Look at example first. Okay, you see? A cube of size 15 centimeter. Okay, so that means a cube every side are the same. So 15 centimeter is placed inside a electric field. The one enter from one of the surface is 250 Newton per Coulomb. When it came out, it become only 242 Newton per Coulomb. Question is, find the charge enclosed in the cube. Okay. Okay, answer. The formula is we're using Gauss law, right? So formula is delta phi is equal to Q enclosed divided by epsilon naught. So our Q enclosed is equal to epsilon naught multiplied by delta phi, which is this one. Phi out minus phi in. Okay? But we don't have phi, right? But you have surface area, isn't it? And E value. So you break down this one into its subsidiary, what we call it, the equation. Phi out is equal to the E out multiply or dot A, isn't it? And minus this one, in dot A also. But the dot product give you what? E out A cosine theta in, out, and minus E in multiply A cosine theta in. And of course the area are the same. Look at the area, in and out are the same because they are cubed. So the area is 0.15 square because 15 centimeter. So we take out the 1 cm, yeah? So epsilon naught A E out, but what is the cosine theta out? 1, isn't it? Because the theta is 0. Okay, the theta is 0, so this one 1, gone. This one also gone. So you just simply need the E out and E in. Both are given. Okay, both are given. So we put in the value 8.85 10 to the power minus 12, 0.15 square. Out is 242 minus in 250. Okay, value is coulomb. Okay, calculate. Of all the Gauss law questions, this will definitely come up.
Cos theta.
Okay, what's the value? It is a negative value, right? So, berapa? Negative berapa? Huh? 1.1. Huh?
1.59.
5,
9.
9. 10 to the power negative 12. Okay?
Yeah.
10 to the power negative 12 coulomb. Right? Others can get the value?
2 years.
Syntax error.
Syntax error. Throw the calculator and throw yourself out of the door. Okay, so I see you next week. Next week we are going to do experiment number. We don't go according the leg manual. We start with leg 2, right?
Yeah.
And then we don't do leg 1. Okay, leg 1 is out. So we have leg 2 this week. Yesterday we just did leg 3. So after that we go to leg 4. Okay, it's actually your third leg lah. Okay, we call it leg 4. Okay.
Simbol dia C kan sir?
Huh?
Simbol C kan?
Coulomb. Stop.
Bye, sir.
Off.
Thank you for the video.
Stop there.
Hai.
Kecau.